Welcome to True Stories in Tech. My name is Eric Klaus, and I'm here today with Brian Enuma, President of Strategic Systems Group, Eddie Bader, President of Company Built, and Manish Bardia, President of Think AI Consulting Corporation.
Hey, Brian, do you have any story to share here?
Oh, very good. Yes, I was thinking about an in-person event that you and I did at Chapman University, and I don't remember exactly what the topic was, but it might have been something on the cloud or something like that. But we ended up with a pretty good audience at the beginning of the session. So I think we had maybe 50 or maybe a little bit more than 50 before the break. And
Yeah.
then we ended up doing our bit before the break, and maybe we broke a little bit too late, possibly. But after the break, I think we had like 15, maybe 20 at the most. So half of them disappeared after the break. We kind of thought back to what went wrong, and maybe one of the lessons we learned was that we had used a really, really interesting title to draw people to the event, and maybe the content was disappointing, and maybe that was part of our downfall there. But I do remember one bit of humor that I tried to put into the presentation. So we had a picture of Cookie Monster of kind of looking up, and I think was about to press a key on his keyboard with the caption "Delete cookies." So this meant to be humorous in a sense that the Cookie Monster wouldn't want to delete cookies. But I think the more interesting bit of humor was that when Manish kind of asked me about the picture, he said, Brian, why is that funny?
I remember that. So the topic on that particular event was how Fortune 500 companies use cloud to improve productivity. So really interesting topic, but I think we did not do a good job on matching the expectation or the content with the topic, what we had promoted.
I think another potential problem was that our slides, while they looked good when we were developing them, maybe their resolution on the projector wasn't as high, and some of the slides end up displaying a little bit funny. And I think we got a complaint or two from that.
Yep, all the things that can go wrong when you're doing a live presentation, especially in an environment that you maybe haven't been in before, so you don't know how it's going to respond to the technology that you're using. We've certainly seen that one happen, Brian, what you just hit on there. You know, you plug in your PowerPoint and go to present, and the colors are off on the projector that you're now connected to. They looked fine when you looked at them, 20 minutes earlier, but now all of a sudden, it looks wrong. These are the perils of live presentations. All right, let's dive in. Today's topic is IoT, Internet of Things. And so we're going to dive right in. And Eddie, what is IoT? What is Internet of Things?
Thanks, Eric. So the textbook definition would be the extension of internet connectivity into physical devices and everyday objects. And what that really translates into is now your refrigerator is connected to the internet, your TV is connected to the internet, your watch is connected to the internet. If you're in a manufacturing facility, all these machines and equipment can now speak to you, for lack of a better phrase, using internet connectivity and technology that allows you to communicate in almost some ways it's unidirectional, some ways it's bidirectional, but it's really the idea that we live in a very connected world, and these are everyday things that used to not be able to do this, but through various forms of hardware and other things, other methodologies, they're actually all tied together and can communicate not only to a central location, but in some cases to each other for different purposes. So in a nutshell, that's kind of what we're talking about with the Internet of Things.
Fantastic. So it sounds like we've got a bunch of different types of devices, potentially all connected to the internet, all sharing different types of data. Manish, what kinds of businesses can benefit from IoT?
Eric, thank you for the question. I want to tag along with the answer Eddie has provided. So with IoT, what's happening is the small devices and things can take information from the cloud or from the external system and respond to the request or actually supply data. So if you talk about things which can talk back to the other systems, the value is huge to all kind of enterprises or all kinds of size of businesses. So whether we talk about mid-size, small size, or enterprise companies, all can get help. I'll give you a quick example on these. Small business, they can track the assets they have. So the asset could be small tools or even important like furniture in doctor office. So we are talking very small business can also start tracking things using IoT. And you talk about mid-sized businesses, think about a trucking company or a logistics company has 20 vehicles, maybe 20 limousines, and they want to track certain things. So they can start using IoT to track their devices, in fact, track the assets within the devices like iPads and other things. Enterprise systems, of course, they are always after efficiencies, so they can start tracking their assets. So all kind of businesses can get help. In addition, in personal day-to-day life, also you can get help. You can put a tile kind of IoT, in the marketplace. You can find some IoT which can track your personal assets like luggage or laptop. So that is one example of using IoT in all aspects of life and enterprises.
So it sounds like this is becoming very, very commonplace. Eddie, are there particular roles within an organization that should be considering IoT?
You know, I do think there's certain roles. I would generally say that every person in a leadership role should be kind of passing their operation through the filter of the Internet of Things to see that if there's a way to use it to become more efficient. I would also tell you that in particular, with a particular focus on any departments that have high labor costs, any departments that are focused on maintenance or have a lot of machines to maintain and make sure they're running properly, and also anybody who's responsible for fulfilling some kind of order. And I'll kind of explain what that means. So I have two examples, and the first example is big belly trash cans. So these are IoT connected trash cans, and you'll see these in different areas. I happen to see these on campus all the time, and they run on solar power. They do have a compactor in them. They have one for trash. They're usually in pairs, one for trash, one for recycle. And you can get a lot of waste in those and recyclable materials, and because they compact, it reduces the need for them to be emptied on a more frequent basis. The other thing is that because they're connected to the internet, they can actually tell whoever's managing them that they need to be emptied. This trash can will say, "Hey, I'm full, so come pick me up." So when you think about that from an operational standpoint, typically when you have a maintenance group, they'll go around and they'll check all the trash cans every day. But unless there's a need for it, do you really have to do that? So you could, in another way, just go and pay attention to the ones that need immediate attention. So anyone that's saying they're full, you go to those, you change them out, and you become more efficient. So instead of spending, 8 hours a day collecting waste from, this campus, maybe you only spend 6 hours, and in that way you become more efficient and you've addressed the serious needs. Because let's say I have on one end of the campus, I have 2 trash cans that are overflowing, but I don't get to that route until the end of the day. Then there could be a lot of discards, that are ended up around the trash can instead of in them, and that affects your operation in a different way. Now the place looks dirty, and it looks unkempt, and so it's a different way to think about how to process your work. So you have to be able to be open to that. The other thing is let's talk about heating fuel. So in the same vein, usually the heating fuel trucks have a typical route, and they go and they kind of fill tanks for houses so that they have the proper heating fuel. But again, if you're only doing it in a just a pre-formatted routine or route, then you'll hit people that you'll stop by, they don't need any fuel, and you'll hit others that have been waiting for fuel. So this whole IoT has been actually implemented in a situation like that, and they've actually found that if they put a sensor in the fuel tank, it'll actually tell the drivers which ones need to be refueled right now. Not only did it conserve time, and it made them more effective because they were actually going to the people that needed the fuel right now, but they also had an increase in fuel sales because they're servicing those needs much more quickly. So it's a really interesting business model as well to consider. So to bring that back to your question, I would say that, again, going back to everybody, because you kind of filter this technology through their operation to see if there are similar advantages that they can gain from implementing this technology.
Thanks, Eddie. It sounds like this isn't just an IT function. This is really an executive level decision process that organizations need to take part in and be looking at. Brian, how can organizations benefit from IoT?
It's a really good question, Eric. Thank you. I'll try and answer this at two levels. One of them is maybe more general in nature. So what I've seen in many instances is that there is an opportunity to do some things that relate to, say, power consumption. And one of the things that comes to mind is I guess co-location facilities, for example. So co-location facilities have lots and lots of computer equipment in them that they're kind of charged to provide electricity, air conditioning, and a controlled environment for the equipment that's in there. The electricity consumption is enormous, as you might guess. But there are some ways to go and gather data from either pieces of equipment or from sensors in the co-location facility to control the utilization of certain parts of the electricity, to kind of maybe power down certain sections or to turn some things differently from an air conditioning perspective if the power consumption is a little bit lower. The other thing that comes to mind is I guess I'll call it HVAC and lighting. So heating, air conditioning, ventilation, and lighting kind of all go together in a particular building, office environment, for example. So there are some pretty neat applications where the lights, for example, have sensors in them, so they can sense movement or they can sense changes in temperature, and be able to transmit to the HVAC system to say, yes, no one is here, people have gone home at night. How about if we turn down the AC so that it conserves electricity? Also the same thing for lighting. So if people aren't in the building working at night, the lighting shuts down and again conserves electricity. So those are pretty general and sometimes very practical ways to use IoT. In something that's more specific, so we have clients that are manufacturing clients in nature, and they manufacture various things from small individual components to large pieces of equipment. So there are some interesting things that take place at the equipment level. So each piece of equipment can be equipped with sensors to throw off, say for example, temperature, vibration, and air pressure. So those bits of data get transmitted to an IoT application that might exist maybe partially within the facility, and more likely the bulk of the application exists outside in some cloud environment that's capturing the data. So with this information that's coming from the equipment, it's possible to look for certain things that relate to failures. So the notion of predictive maintenance comes to mind. And rather than being preventive in nature, it's predictive, so that before the machine actually goes down, there's an opportunity to go and apply a repair or an update to software or a replacement of a component before a problem actually occurs. And the savings for a manufacturing organization are quite large, because the cost of a machine going down in the middle of a plant's operation, that has lots and lots of ramifications for labor and for delivery of parts to customers. It's just enormous. The other part of manufacturing that benefits from IoT is the movement of inventory. So certain pieces of inventory can be tagged with RF sensors or things that throw off Wi-Fi signals to be able to track the location of materials within the plant, and the movement from the warehouse to the operation for manufacturing, and then back out to finished goods inventory. All of that movement is very interesting to capture, and then it helps people to be more efficient about how they pull material and how they ship material. The other part of manufacturing that is interesting to capture is the application of labor. So one of the key elements of manufacturing is to track how much manpower or how much machine time is being applied to a certain set of goods that are being manufactured. And IoT sensors can be attached to any part of the operation, including how people are working with parts and then moving them to the next operation. All of those things have some very large ramifications for manufacturing organizations that they have a pretty high cost structure.
Wow, so we've heard organizations can benefit in a lot of different ways, from efficiency, from potentially even increased sales, a lot of real world benefits to organizations around IoT. Manish, how does cloud impact IoT? Does an organization already need to be, in the cloud in order to use IoT?
Eric, that's a good question. I think sometimes it becomes confusing on IoT versus cloud, and if the cloud is a mandatory in order to start using IoT. So first, let's confirm that you don't have to be already on the cloud. Now, having a cloud strategy, if you're doing IoT, definitely helps. But in order to do IoT, you don't need to be on the cloud. Cloud will provide you much better environment to maximize your return on IoT investments. So as Brian says, there are many use cases where you can have the IoT capturing devices or the devices which is talking to IoT internal to the organization, which are not even connected to the cloud. However, if you want to centralize the management or the data collection of all these IoT deployments, then a system like cloud can be helpful. However, there are scenarios where you don't have the option of connecting to cloud, or you are not connected consistently or constantly, and actually on different ways you can take the data and publish to different systems. So cloud is not a must, but some benefits I want to highlight about having a cloud ecosystem along with your IoT system are that there are analytics modules already available, data modules already available, which will allow you to have much more intelligent decision making with the help of IoT devices, and you can monitor and make certain adjustment or changes based on the data you're seeing in real time. So that's how cloud is connected with IoT.
Fantastic, thank you, Manish. So Brian, what are the important elements of an IoT solution that someone should consider before getting started?
That's a really good question, Eric. I guess fortunately or unfortunately, there are a few things to consider. The most simplistic might be at the level of the sensor. So whatever the sensor is, it could be some piece of software running on a piece of computer equipment, or it could be a physical device that's measuring the temperature, vibration, and air pressure, for example. but the sensor is kind of the very base level of the components needed. In situations where movement is occurring, that sensor might throw off location data in terms of where it might be in the plant at any particular time. Once the sensors are set and throwing off data, there's something that is referred to, I guess, as edge processing. So edge processing is the servers that exist in the facility behind the firewall, and is used to capture the first set of data that comes through from the sensors. The reason for this particular set of equipment on the edge is to go and do some pre-processing. So while it's possible that all the data is important, it is more likely that only a component or a section of the data is really useful. So from that perspective, the edge processing provides a way to filter the large masses of data that are being thrown off by the sensors, so that not all of it goes off to the cloud for storage and for analysis. So once past the edge, that's where the internet comes to play. And sometimes they're private data circuits, but more likely it's going to be a public scenario where publicly it's passing from the location to the cloud through a secure channel along the internet. So once it gets into a cloud environment, there are bound to be servers set up to capture the data, and then more importantly to process. The equipment that's in the cloud could be very simple in the sense that it's just a data capture mechanism and storing data onto virtual drives, essentially, in the cloud environment. But it could be a little bit more interesting and more complex. So once the data is there, the question then arises, okay, now it's here, what do I do with it? So there are two things that come to mind that once the data is there, and it could be in various volumes of data. So it more likely than not is going to be considered big data because the sensors just throw off lots and lots of data over time. But it could be smaller sets of data that aren't quite as massive. But the two things that are kind of interesting about it is that with the data, you can then do some analysis. And it could be as simple as Excel spreadsheets, but it could be as complex as data visualizations through some Power BI tool or some kind of business intelligence application. The other thing that's important, or at least interesting, is the ability to apply artificial intelligence to the data. And more likely than not, it'll be a machine learning algorithm of some sort that will look for patterns in data to be able to predict certain events. So in the situation I mentioned earlier about predictive maintenance, the data that comes through from the sensors and collected in the cloud environment can be used to conduct some machine learning algorithms so that we can predict when a machine failure might occur before it occurs. And that kind of application of AI is very useful, and it does have some powerful benefits.
Wow, fantastic. All right, so I think we've intrigued people hopefully by now about what IoT is and how they can benefit from it. Manish, how expensive is an IoT solution? What kind of businesses can really afford this?
Eric, this question is actually a little bit tied to the previous question, which I touched upon, is what kind of businesses can use IoT? And the scenario we saw, and even Brian highlighted, was the different kind of devices companies can deploy with the help of edge computing. So here what we need to be talking about is the use case regarding the IoT device. And simple example is, you have the temperature sensor in your home, which is just sensing the temperature and controlling your air conditioning. And that is like $100 device. But when you talk about a small business and all they're trying to deploy is maybe 10 of specific IoT devices. So the real investment on the device is varying, but the solution, what comes after the data is collected using IoT device, will define the actual cost of your IoT investment. I would say deploying the IoT devices, which is just capturing data and reporting back, is not costly. However, using the whole ecosystem on IoT and then going to the extent of making the business intelligent, the BI solution like on Power BI dashboards and running the analytics and making decisions or predicting the future events goes into much complex scenario. To answer the question, basic implementation of IoT will not be costly, but as you become more advanced in the use of IoT devices and the data, that will increase the cost. I want to highlight on this the terms we use in the business intelligence, which is whether the reports are for the historical data, real-time data, or predicting the future events. So whenever you are reporting or just looking at the historical data, it's the past data and it's not much complex scenario. So thus the investment will be low. As you talk about real time, so you're looking to be having connected environment, connected deployment. So the cost has increased, and now you go into predicting the future events. That's where the cost will be more. So that's where it will become costly. I think you had one more small question on the follow-up that what kind of businesses can afford. I would say that is not the criteria here. Even small businesses, individuals, mid-size enterprise, all can start using IoT in some manner.
Fantastic. Thanks, Manish. So, Brian, maybe you can help us with this one, but what are some of the risks involved with an IoT project?
That's a really good question, which sort of touches on the business applications of IoT. So let me see if I can maybe work on this question in sort of phases, if you will. So I think that there's Peter Drucker said something along the lines of that there is nothing more useless than expending great time and effort and efficiency on working on the wrong problem. So the notion is that applying IoT to everything is probably not the right solution. Applying IoT to a specific use case that has maybe a fairly narrow domain might be a reasonable way to approach it. So I guess the largest risk of an IoT project is to work on an IoT application for the wrong reasons. That said, there's an element of maybe trial and error involved, and I think that this occurs with artificial intelligence as well. So the trial and error process is that, well, we think this is a situation where IoT can help. We're not real sure, but we can gather some data on a very small sample basis to kind of make some determinations about, yes, this is great, or no, we should think about something else. So rather than trying to approach a project from a, I guess I refer to as waterfall scenario, trying to build the whole project out, expend all the resources, and then test it is probably the wrong thing to do. So rather than do something in a waterfall methodology, to follow an agile approach instead. So go and pick a domain, a fairly narrow problem, and then to run some fairly inexpensive tests and kind of gradually build up to a situation where you have enough data to confirm whether or not the use case is worth pursuing. There's a business element, as I mentioned, where that there could be a situation where the IoT solution actually works. It's actually able to predict, but the amount of money it saves might not have been as large as originally predicted. So in those cases, it was a situation where, yes, it was successful, but maybe from a business perspective, it didn't really pay off. So I think those are the risks that come to mind right away.
Very good and very insightful. Thank you, Brian. So I guess, Eddie, we'll start this one for you, but if someone wants to get started with IoT, what are maybe a top few things that they should do?
Well, the way I would approach it is really from a business process perspective. So again, as I had mentioned before, I would look at where I'm spending the most labor, where I have any issues of response time or where response time is critical, or can be time indeterminate. So I do have a set of work to do, but I don't necessarily need to do it at this moment, and I can manage it whenever it fits in the day. Having information that allows me to put my effort where it's needed the most is also a more efficient use of your labor. So opportunities like that, I would identify all those processes. I'd also sit down and identify how much money I think I could save if I could actually manage these things more efficiently. And I would also look if I have a lot of machines or machinery and maintenance is an issue. So let's say I run a bottling facility. Let's say I have a Coca-Cola bottling company and I run that facility 24/7. If I have to take one of my bottling machines offline, how much does that cost me? In terms of I didn't do the maintenance in time, so now it's going to be down for 24 hours instead of 4 hours because I didn't order the part, I don't have it to replace it, and so think of all the money, the opportunity cost there, the lost money from not having that line open for 24 hours versus 4. And not only do you start developing what needs you would have to be able to identify these maintenance opportunities ahead of time, but you also start to develop a budget. So, there's always going to be some kind of expense with implementing this type of solution. But if you realize that if I'm just down for 24 hours, it's going to cost me, this much in dollars, maybe we'll say $20,000. And if it happens, 6 times in the year, that's $120,000 versus this project's only going to cost me $40,000 to implement. I just kind of bought myself an insurance policy, if that makes sense. And then lastly, before I do anything, before I even have the project started on, I would consider looking at possible partners to help get this work done. Especially, there are a lot of people that can do it. Some are really good. I would find a solution provider that has experience in your industry and has proven that they can deliver the solution. A lot of people say they can do things, but when it comes to delivering, sometimes they can't. And I wouldn't just pick the first person that you find. I would do some research. I would bring them in. I'd interview them. I'd get those references. I'd look at the applications that they've produced, and the applications being where they've implemented IoT and what the results were, and really look at not only what those projects cost, but what they ended up saving those companies, and really kind of do a full circle research on the program before you even spend any ounce of other than the money that you pay your people already. I wouldn't spend any extra money until you did all that research and homework.
Brian, do you have any things to maybe add as well?
Thanks, Eric. Eddie raised some very good points, so I only have a few things to add. One of them is about the use case. So we talked a little bit about the business problem, and I think it's really important to identify a business problem that has a payout. So if the business problem gets resolved, that there is indeed an estimated ROI that comes from an IoT project. I think it's very important at the very outset to at least guess, at least estimate what the ROI is going to be before spending the first dollar. So that way you have some sense about where you're going. The second thing that comes to mind is to find some other folks that have done what you're planning to do. So in addition to going and finding a good partner to help you, there's probably an argument to go and find some other companies, some other organizations that are in a similar boat that have implemented a project successfully, and then to see if you can learn from their mistakes so that you can avoid some of your own. The last bit that we talked about earlier was taking an agile approach. So my sense of an IoT project, and this probably applies to almost anything, is to go and take something small, start small, give it a test, see what kind of results you get, and then go on to the next step that might be a little bit larger. So I think in general, if organizations start down the road of an IoT project, if they keep things small at the outset, they have a better shot at getting to the end goal without having unnecessarily spent a bunch of money.
Fantastic. Well, I think we've learned an awful lot today about IoT and how organizations can benefit. We've talked a little bit about costs and risks. I really appreciate the conversation and all of the feedback from everyone today. Thank you. From the True Stories in Tech podcast, I'm Eric Klaus. Make it a great day.